Good morning, students. Yesterday we discussed about the introduction part of the gravity dam, also the forces acting on the gravity dam. Among them, yesterday we discussed about the water pressure, the uplift pressure, and today we will discuss about the earthquake force. I think everybody is aware of the earthquake force. If you'll see the diagram of the earthquake, its origin is called inside the earth's surface is called the focus. When it appears in the surface, this is called the epicenter. And this earthquake force travels in the vertical direction and it appears in the surface as a vertical acceleration and notation is alpha v, and this value varies the sum part of the acceleration due to gravity, that is its range in between 0.075 g to 0.15 g, and in the horizontal direction the horizontal acceleration, the notation is alpha h, and its value ranges from 0.1 g to 0.2 g. So this acceleration, whether it is a vertical acceleration or the horizontal acceleration, we can understand by the sum of its derivations. Let's see one by one. Let us first consider the horizontal acceleration. By the horizontal acceleration, we can also compare the vertical acceleration. The general formula of horizontal acceleration is, that is alpha h is equal to k times g. Here k is the value which we have already discussed, the value of horizontal acceleration, that is 0.1 g to 0.2 k, g. Here the value of k is 0.1 to 0.2. So the question is that the value of k, how does it come? So the value of k comes from this formula. K is equal to beta into I into alpha naught. K is called the seismic coefficient. Seismic coefficient. Seismic coefficient, where beta is what? It is the soil foundation system factor. Soil foundation system factor, and whose value is 1 for gravity dam. The value of I is called the importance factor. It is I is equal to importance factor, and its value is 2 for gravity dam. And alpha is called the basic seismic coefficient. Alpha is what? The basic seismic coefficient. Basic seismic coefficient, and this value of alpha naught depending upon the zone. We know that India is divided into 5 seismic zones. Let's see the table first, then we will try to understand. Here there is a 2 column. First one is zone and second one is alpha naught. So for zone 1, this value is the value of alpha naught is 0.01. For zone 2, the value of alpha naught is 0.02. For zone 3, the value of alpha naught is 0.04, and for zone 4, the value of alpha naught is 0.05. For zone 5, it is 0.08. So we can easily understand how the value of alpha V and alpha naught comes. Now let us understand how does it affect the dam which is constructed on the different zones as far as the zones are concerned where the gravity dam exists. Then first we'll see the effect of horizontal acceleration due to earthquake force. So number A is the effect of horizontal acceleration. The horizontal acceleration affects the dam in two ways. The first one is the inertia force, that is inertia of the gravity dam. And number two, the hydrodynamic pressure. This inertia force affects the stability of the gravity dam. And this affects the hydrodynamic pressure, affects the stability of the water of dam reservoir. Now we'll see the inertia force. Inertia force is what? Whenever the horizontal acceleration acts on the dam, it tries to dislocate the body of the dam, and it always acts, the inertia force of the dam, it always acts against the inertia force of the gravity dam. So first we'll draw the sketch and we'll try to understand. This is the cross section of the dam, and here is the weight of the dam. Whenever the horizontal acceleration or horizontal force acts, suppose this acts in this direction, suppose this is Fe, this is the force in the earth due to the seismic force, and due to this force the body of the dam try to dislocate in the opposite direction. That means the inertia force will act in the opposite direction of the force or shaking of the earth. So Fi is equal to mass, that is W by G. Force is what? Mass into acceleration, and we are observing the force due to the seismic action. Okay, so this is mass, and acceleration is what? Horizontal acceleration, that is alpha h. Therefore further we can write it W upon G into alpha h is what? Alpha h is what? K into G. Here G cancel out and we are left with W into K. So the dislocating or disturbing inertia force of the gravity dam is what? K times W. Therefore This is the effect of horizontal acceleration, that is the inertia force. Now the second one is the hydrodynamic pressure. Hydrodynamic pressure. When the horizontal acceleration acts in the water of the reservoir, it shakes the water inside the reservoir, and this force will act on the massive structure of the dam. And this whole analysis was given, rather we can say the formula was given by the von Karman, and von Karman has given its own empirical formula. So let us first understand the hydrodynamic pressure that is acting on the wall of the gravity dam. So first we'll draw the sketch and we'll try to understand. As per von Karman, the variation of the pressure, that is hydrodynamic pressure, is parabolic, and this pressure will act in this direction, that is at the wall of the dam. Suppose this resultant force is over here, that is, suppose this is Fw. Fw means what? The hydrodynamic pressure. The value of Fw is equal to 0.555 gamma W Ke h square. This formula was given by von Karman. That is why it is called a von Karman equation. And the value of Ke lies in between 0.1 G to 0.2 G, which we have already discussed. And this height, the height of the force is 4h upon 3 pi. Now let us move ahead towards the effect of vertical acceleration. That is, effect of vertical acceleration. Whenever the force tries to move in the upward direction, it may be upward or downward. Whenever it acts in the upward direction, it will try to increase the weight of the body, effective weight of the body of the dam. And when it acts in the downward direction, that means the foundation will try to move far away from the massive structure of the dam. That means the effective weight of the dam will be decreasing. So the formula will be Fv is equal to mass into acceleration. Mass is what? W by G, and this is G. When it acts in the upward direction, it will be plus alpha V. It will added at the amount of alpha V, and when it acts in the downward direction, it will reduce the effective weight of the dam. Therefore, we can say that it increases or decreases the effective weight of the dam. Here plus sign for upward direction. and negative sign for downward direction. I hope this whole thing is clear to all of you. If any doubt, you can comment in the comment box. Thank you.